training today, and we will go ahead and get started. Let me make sure it's recording. Awesome. Okay. So I'm going to share my screen and go ahead and get underway with you guys. All right. So second grade quarter 3 science preview today. We're going to start with some announcements and updates from the science department. So go ahead and mark your calendars for our next virtual CCC meeting date, which will occur via Teams like it did this past week. But our next K2 grade level band science CCC meeting is going to be March 15th. And as always, the meeting will be recorded and posted to our grade level science teams for later viewing whenever you get a chance. We do have some updates for you on CTLS. We have uploaded quarter 3 science workshop model units for you, and you can find those underneath the topic navigator tab. So you're going to come to your course navigator, and then you'll scroll down to topic navigator. You'll select the drop down menu for the topic that, or the unit that you want. And once you're in that unit, you will scroll down to instructional strategies. And at the top of that is where you will find your science workshop model unit plans for quarter 3. We do have a virtual field trip document uploaded to the course resources tab for you. Kelly Bodner did a great job coming up with those, and it is a workable document, so you can add to it if you need to. And then, of course, we would love to see your really cool science going on when we get back and you get back in the classroom. We know we can't join you in person, but you can send us a link if you're doing a cool lab or investigation, or maybe having a virtual science event at night at your school. Please, we created a Microsoft form for you to fill out to let us know when and where, and give us the link and all that good stuff that you have going on in your school. So let's hop right into quarter 3. Here we go. Here's what we're going to be doing today. We're going to go over those quarter 3 science standards, and I'm going to give you some teacher content knowledge to help you and your instruction of those science standards for your students. We're going to look at those unit plans, and I'm going to give you tons of lesson resources, phenomenon, and some really cool lesson resources that you might not have seen yet before. And then we'll have some time for questions and feedback in the end. All right, so let's look at our second grade science teaching and learning framework. This is going to pop up when you go into your second grade science course. It will be under the course navigator tab, and this is your pacing guide for your science standards for the year. Today we're going to be looking at quarter 3, units 4 and 5. We have a suggested pacing for you, 4 weeks and 5 weeks, and we have seasons, shadows in the moon, and environmental changes. My suggestion to you is I love downloading these frameworks and keeping them in a notebook where I have all of my lesson plans. If you do it digitally, you can save it to a OneNote or something like that, so you have it readily available for you as you're planning out your daily instruction. All right, so let's look at our standards for quarter 3 for season, shadows in the moon, which you hit up first for 5 weeks. Know that all of our Georgia Standards of Excellence in Science start with the first 3 science and engineering practice words, which are obtain, evaluate, and communicate. They are embedded, those SEPs are embedded within our standards, and you can see that I've unpacked our standards by highlighting those science and engineering practices and what we're asking our students to be able to do. And I'm going to give you ideas on how to assess them on that standard as well. So for our first standard, we have attain, evaluate, and communicate information regarding the sun and moon and the sun's effect on Earth. Specifically, element A is carry out an investigation to determine the effect of the position of the sun in relation to a fixed object on Earth at various times of the day. So we need students to get to do hands-on science with this. They need to carry out an investigation. You're going to plan that investigation together. And the easiest way to do that is to have your students look at that little picture I have up there. You can have your students go outside to see what their shadows look like throughout different times of the day. It's as easy as that. You can even let them come up with an investigation or a way to see the position of the sun in relation to that fixed object throughout the day, and you're going to need to take some data on that. Element B is design or build a structure to demonstrate shadow changes throughout the day. This is your, run of the mill. We can build a sundial, we can do a Lego person, we can build a aluminum foil structure, but they're actually designing it and then carrying that out through a build to demonstrate, and you'll need to take it outside. So you're going to want to do this on a day that is definitely sunny or partly sunny. C, represent data in tables and or graphs of length of day and night and seasons changing. So this can be accomplished by giving your students a blank data table where they write down sunrise and sunset each day, and then you can work as a whole group to figure out the length of the day. And then our last element is describe, illustrate, and predict how appearance of the moon changes over time. So I'm going to give you some examples of ways to do that. But let's talk about shadows, seasons, and the moon really quick before we go to. Let's just talk about some background knowledge that teachers should have so they can actually teach this to their students. So think about this. Perhaps in the past, people were even more aware of the stars and the patterns of the sky because we needed the knowledge of the sky patterns as they related to seasons, because it was helpful for people that planted crops or navigated boats, right? But learning about objects in the sky should be entirely observational and qualitative in the early years. So really, we want them to observe it, and then we want them to talk about it. Notice that I didn't say quantitative, and that is, when we look at data tables in science and things like that, that is quantitative, but we really want it to be qualitative in the primary years. So really the main objective of this unit is to get students noticing and describing what the sky looks like at different times. They need to be able to name, they do not need to be able to name the moon phases. That comes later in 4th grade. However, they should observe how it appears to change its shape and its location in the sky. So they should recognize that it looks a little different every day, but looks the same again about every 4 weeks. They should know that the moon can sometimes be seen at night and sometimes during the day, but that the sun is only seen in the daytime. And by the end of 2nd grade, as a teacher, you should expect that students would know that the sun, moon, and stars all appear to move slowly across the sky. And to help you with that, just to give you a little bit of teacher background knowledge, is the Earth and other planets in our solar system, they revolve in an elliptical orbit around the sun, which remains fixed at the center, right? So we know that it takes the Earth 365 days to complete an entire orbit, and that cycle makes up our year. But as the Earth is orbiting, it's also spinning on its axis, which means that a different part of the Earth's surface faces the sun during a 24-hour period. You can demonstrate that with your students. This is not direct instruction pieces that you want to share with them, but you can let them know that. You can extend their thinking a little bit by showing them a globe or a time-lapse video. So because it's spinning on an axis and we see a different part of the Earth's surface facing the sun during 24 hours, this also makes it look like the sun is moving across the sky during the day. And and it appears to move from east to west. And that path can be followed using a fixed object like our element A, like a tree, a pole, or some sort of reference point, because the sun shines all the time. And that's a big misconception that early science learners have. So the spinning or the rotation is what makes the day and night. We really want them to understand that. The position of the sun determines the length of the shadow. So shadows are shortest at noon and they're longest in the evening and morning. And a sundial uses a shadow to mark the time. And it's the Earth's tilt that causes those seasons. And that means here in Georgia, the northern hemisphere is tilted toward the sun during our summer. But when the Earth revolves around the sun 180 degrees, the southern hemisphere is then tilted toward the sun. So we experience winter, and that's what we're experiencing now. Contrary to like what people really think, is the Earth is actually not closer to the sun during the summer. And that's not why we have warmer temperatures. The reason temperatures are warmer is because the sunlight hits more directly, which concentrates the heat in a smaller area. And due to the tilt and the shape and the path of our orbit, days are longer in the summer than nights. And in winter, the opposite, the days are shorter. With our moon phases, Just letting you know that the moon is the Earth's only natural satellite, okay? So although the moon appears to give off light, it's really only reflecting light from the sun. And moon phases result from the relative positions of the moon, the Earth, and the sun, and the amount of sunlight that's reflected by the moon that's visible from the Earth. And what's really cool and that kids might not know, but you can go ahead and share this with them, is that the Earth's moon orbits in the same direction as the Earth rotates, which is counterclockwise. And for our students, the moon appears over the eastern horizon about an hour later each day. And what you see when you look at the moon depends on its location in relationship to the sun and Earth. The moon never goes away or changes shape, but reflects a different fraction of sunlight to the Earth, depending on where it is in its orbit around. So for example, when the moon is in between the sun and Earth, we see a new moon. When the Earth is in between the sun and the moon, we see a full moon. We're able to see the full moon most months rather than having like an eclipse every month because the moon's orbit is slightly about 5 degrees off from the Earth. So that's just giving you a little bit of background knowledge about shadow seasons and the moon. So let's hop over to environmental changes. Our standards for this quarter are obtain, evaluate, and communicate information about how weather, plants, animals, and humans can cause changes to the environment. And then we have a clarification statement. That's just to help you understand what exactly the students need to be able to do and know. But changes should be easily observable in second grade and could be seen on school grounds or at home. So we're not asking you to show your students, deforestation in the rainforest, but something locally that they have a connection to would work best at this age. So unpacking those elements, we have element A, which is ask questions to obtain information about major changes to the environment. And B, construct an explanation of the causes and effects of a change to the environment. So this is going to come about using a natural phenomenon, and I have an example to show you. But what you need to know as a teacher in order to teach these standards are that changes in the environment are important observations for second graders to start making. They need a strong foundation for being really good observers in the community, as well as problem solvers when they see negative changes occurring. So the environmental changes that students may encounter and identify at this level are divided into 4 categories, and that's human changes, weather changes, animal changes, and plants. So human changes to the environment can be positive or negative. Negative changes could be pollution. Positive changes could come in the form of conservation or beautification if you have days like that at your school. And students might observe trash on their school campus or notice maybe some nature trails that have been worn by students in particular patterns. Or you might notice, some erosion near a field or a track or a playground. They might also see new construction in an immediate area, which also results in changes that may be negative for the plants that were moved, but also positive for us as people. So it's important for them to start weighing the positive versus negative impacts of people on the environment, and that will help them with elements A and B. So weather changes, of course, happens to our environment in quick ways, like sudden storms, washing away soil, plants, all that. And also weathering and erosion, wind and water erosion, that happens slowly over time. So students might see evidence of bad storms in their immediate environment. And then animals, of course. Animals can change the environment when feeding, moving, unfortunately, animal droppings. Students can see evidence of animals probably in their area, both on the ground and through careful observations of plants if you have a garden as well. And then plants, of course, can change the environment by spreading into new areas and sometimes through invasion of plant roots into new areas. So think about kudzu. That's a great phenomenon to use with environmental changes. All right, so let's get into some resources for you guys. All right, so we know, I've already mentioned it before, that phenomenon drives our instruction in 3-dimensional science. And phenomenon also brings about student questioning. So in 3D learning, the questions drive our instruction. So you're going to present students with an authentic phenomenon for each of these units. And then the students are going to come up with questions and you're going to write them, or they can post them on what's called a driving question board. And you're going to use those questions to motivate the students to do their science workshop model work session stations. That's when they're going to be using those science and engineering practices to answer those questions. And also you're evaluating their answers as they go to determine if they've answered a question about the phenomenon or if they have more questions. And keeping that driving question board up for the entire unit and coming back to that phenomenon every day is going to allow students an opportunity to communicate their findings and their science thinking with you. All right, so let's talk about seasons and shadows. So our anchoring phenomenon is a really cool 24-hour time-lapse video that I found for you guys. And here, I'll just go ahead and click on it so you can see exactly what I'm talking about. This is from The Wonder of Science. And you'll just watch this quick 15-second video. You can see the sun go up. You can see all the shadows moving. There's so much going on in this phenomenon video. You could watch it every day and notice something different. But this is a great way to get that questioning activated with them. And then I have some guiding questions for you, like what caused the shadows to form in the city? How did the position of the sun change throughout the day? Did the sun or earth move during the day? So we're going to use that to activate their prior knowledge and to drive our instruction for the shadow and moon unit, okay? So you have a science workshop 2-week unit for this standard. So you'll start with a phenomenon on Monday, and then Tuesday through Friday of the first week, you will do station rotations. And then the second week, you will do different station rotations Monday through Thursday. And then Friday is an assessment day. So what I have up here pictured for you and snipped for you are some sample activities that are different than the activities that we have already for you on CTLS Teach. So the first one is called Spinning Through the Seasons. It's really just to reiterate what happens through the seasons, how our plants change. It's a wheel. So you have a top wheel, you have a bottom wheel, you have little pictures that they cut out, and all you need is scissors, glue, and a brass brad to hook it all together. I am going to stop sharing my screen for 1 second so I can show you exactly what this looks like. This is the Spinning Through the Seasons. So you have a little spinner and you have the students color the trees and they spin through the seasons to see how that tree is going to change throughout the season. So that is Spinning Through the Seasons. All right, the second one is for that element that says we need data. We need to represent data in tables and or graphs about the length of the day and night in different seasons. So this worksheet is perfect for that. So you have how long is the day in each season? Turn this table into a bar graph. So I'm giving you the data. You're going to analyze, your students are going to analyze that data and then create a graph and then write what they can learn from that graph. So we really want to know which season has longer days, shorter nights, which season has shorter days, longer days, shorter nights, all of that, both. So you have one for day and you have one for night. Love that one. And then for that element B, where they're designing and creating a structure, you have your time, your run-of-the-mill make a sundial activity with directions. But like I mentioned earlier, you could also do aluminum foil sculptures of the students. You could do Lego sculptures. You could do modeling clay. You could do stuffed animals. Anything that's going to be a fixed structure that you can take data on and see it's at the same place, you're going out at the same time, and increments of, an hour, 30 minutes to an hour to record what you see. So that is one activity. For our moon, I have some really cute stuff. So of course, with the moon, we want observations. Like I said, for our second graders, observation is going to be key. We want them observing as much as they can, because they start in their brains, they start analyzing what they're seeing, and they store that in long-term memory, and then they're making those connections to the actual science concepts as well. So I have a really cute moon journal, moon observation journal calendar that they can do. And then the moon observation journal that goes with it is they write the date, the time, and the place, what it looks like, and words to describe it. And that's just a little half sheet, a little half page moon observation journal that you can send home with the calendar as well. Another take on that is moon on a strip. Instead of doing it in a calendar, you can actually have them make a strip of a whole month's worth of what the moon looks like, and have them do that with the date. You would just need to cut that out and prepare that for them ahead of time, because that could be a little cumbersome for a second grader. The standard, our lunar looking moon phase cards, the students do not have to know the name of the moon phases at all. These cards just came with it. There is nothing wrong with previewing that content vocabulary with your second graders, but we are not expecting them to know those as well. And then the last one down here, it's called a moon strip. And I actually made one to show you what it looks like. Let me stop sharing my screen so you can see this. So basically, you cut out your 4 strips of the moon phases and put those in order. And then you take an index card and you cut 2 slits and you put your strip of moon phases in front of that. And then you can move your strip throughout the moon phases as well. It does have the names. You could actually print it or cut those names off if you wanted to. Totally up to you. Like I said, they don't have to know the name of the moon phases. But this is a great way, or a great tool, if you're making lap books or you have notebooks or science interactive journals or notebooks for your second graders. This would be a great tool, a great resource for them to leave in their notebooks as well. All right, back to more resources. All right, environmental changes. Our anchoring phenomenon is kudzu. Of course, how can plants change an environment? We know kudzu is a annoying plant that was brought over here from somewhere else. I can't remember. I think it was Asia somewhere, but if you click on here, it's from Wonderopolis. And it takes you through a little video and some reading that you can put up on your panel. It gives them nice visuals, and I promise you they will identify and know exactly what kudzu is just by looking at it. But using that to activate your students' prior knowledge and get them questioning about how plants can change an environment, you'll want after watching the video, students can share those questions out loud with the group. You're going to create that guiding question board. And we do have a 2-week science workshop model unit plan for environmental changes. So same thing, you will use that kudzu phenomenon throughout the unit. You're going to come back to it each day. But here are some examples of activities I have for you for environmental changes. We do have some really good HMH stuff for you to do, but this is an investigation on how a flood can change an environment. A quick investigation. All you need is a pan, some sand, some leaves, and some water, and a book. And you're basically making a stream table with that, and you're looking to see how that water that you pour in affects the environment. So that would be a great investigation for your students to do. The next one, I do have some example photos, an activity where they have a bunch of example photos of before and after environmental changes, and students will describe the changes that have taken place, or they can even write a prediction or what they think or a claim as how the environment has been changed. Has it been changed by humans, by plants, by weather? Those 4 categories that we talked about that they needed to know. Humans, weather, animals, and plants. The next one is my my favorite for environmental changes. I used this a lot when I went into co-teach with the second grade teachers. So you're going to have them do a nature walk, whether it's at their house. Your remote learners can do that around their house, in their neighborhood. You can do this at school, in the playground, or any place that you know has some environmental impacts. You'll have them walk around, and then the directions are draw and describe an environment that you have seen change. Then tell if the change is good or bad. So we're really wanting them to think about whether that human, whether animal or plant change to the environment was positive or negative. So they're going to draw their before picture, their after picture, and then describe the change over time. And then let us know if that good or bad. And you could have them present that to the class as well as a formative assessment piece. The last little snippet picture I have for you over here is from an Ames activity on environmental changes. I think it's called Spot the Change. And you'll have students we'll have two pictures on a page. And here they can color the picture first if you want them to do that. But they're looking to see what the change is before and after. They need to be able to identify that, whether it's human, weather, plant, or animal. And then if it's a good or bad change as well. And then for this one, you can see that the stream has been dammed up and it's created some things right there. But you can also see in the top picture some leaves on the ground. Like, they really have a chance to dig deep and figure out what's going on with the environmental changes that they see. All right, I am going to stop sharing my screen so I can show you. I do have some more examples that has been, here is the environmental change example of what it could look like for your students that I showed you on that last screen. So that's an example. You could put this up as your anchor chart just for differentiation piece if you wanted, just so your students can see exactly what you're asking them to do. All right. Yes, parents can assist if needed with any of that remote learning stuff, especially with the Moon journals and things like that. It's a great opportunity for some family involvement. All right. Okay, any other questions? Camilla, you good? Awesome. Okay, well, that's all I have to share for you today.
Yeah.
Like I said, everything will be uploaded for you with the
Good.
PowerPoint. With the PowerPoint into the grade level teams. So I'm going to stop